Okay, so the DEB mock 2017 paper 2 question 3, the circle question. We did the first part, although I came up with, I think, just a nicer way of doing the second half of it. But the first half was that since the y-axis is a tangent, then the y-coordinate of the centre, which is the minus f part, is on a line. I'm going to put the line in here. It's on a line with that point A. And the y-coordinate at that point A is -2, so minus f equals -2, which means f equals 2. So that's how we get f. And the second part was hence show that c is equal to 4. So you can do it using that radius thing like I did earlier, but I just thought this was a bit nicer. So 0 minus 2, so that's the point A, is on the circle. And we know that f equals 2. So if you take this equation, this one that's up here, and you put in 0 for x, -2 for y, here f equals 2, because the x is here, you see here, so you get x squared and then you get -2 squared. It's 2 times g, and the g would be a problem except that you're multiplying it by 0, so it gets rid of the problem. 2 times 2 times -2 plus c, so you end up with -4 plus c, and then c equals 4. So they were the two answers for that part. The second part there is that the centre of S lies in the third quadrant and S makes a chord of 4√3 on the x-axis. Find the value of g and hence write down the equation. So we had said earlier as well that the radius, because this line is a highlighter, this line across here is the radius, and that line, the length of that line is the same as the x coordinate here. So if we can figure out what the radius is, then we'll know what the g, the x coordinate of the centre is. So I drew this blue line straight up the centre there. If you have a line that goes through the centre, it will be a perpendicular bisector on a chord. So I have the little perpendicular sign in here, so it's a 90-degree angle, and it cuts the chord in half. It's a bisector, so you get 2√3 and 2√3. The length of this little line here is 2, and we can get that from over here because we know that this black line across here is 2 units down off the x-axis, because that's why the coordinates of this are -2. So we know that this is 2, we know that this is 2√3, we have a right angle here, and then r is our hypotenuse. So I just redrew that here to the Pythagoras, and you get that r equals 4. And as I was saying up there, r is equal to g, so g is equal to 4. So then you have f equals 2, you have g equals 4, and you have c equals 4. So I just subbed into that this formula up here again, the x squared plus y squared. So x squared plus y squared, 2 times g times x plus 2 times, that's f, times y plus, and that one's c. Simplify it, and there's your equation of S. Okay, and then the last part is find the equation of two tangents from the origin to S. Let's go back up here. So a tangent from the origin, so the origin is obviously here. So one tangent is kind of obvious, but we'll talk about that later. It goes down this way, and then the other tangent is going to go sort of off that way. And we're trying to find the equation of both of those. So the equation of a tangent is a line, so we use y minus y1 equals m times x minus x1. The point that we're concerned with is the origin, so 0, 0. So I subbed in 0 and 0, and you get y equals mx. So I rearranged that, I brought the y over here, so it's mx minus y equals 0. So what I said was, given it's a tangent, I said the perpendicular distance from the tangent to the centre of the circle, which we now know is -4 -2, has to be equal to the radius. So that statement there is always true for a tangent. The perpendicular distance from the tangent to the centre is equal to the radius. So just apply the numbers that are concerned with this one. So A is here, B is here in front of y. This equation has no c, so c is 0. x1 is here, y1 is here, and then this here, the radius, the length of the radius is the perpendicular distance. So put that into the perpendicular distance formula. I brought this up here as a multiplier, so this is what I have. So I suppose you have two options from here. You can square both sides, or you can let the modulus equal plus or minus this, which is what I did. So this is the one where it's plus the 4, and this is the one you can just see it there where it's minus the 4. It probably didn't matter in this case because normally you do the plus or minus thing to avoid having to square it out, but you have to square it out here anyway because you have square roots. So squared out the left hand side, 16 squared minus 16m plus 4, and I squared out the right hand side, which is 16 times m squared plus 1. Simplify that, handily enough the m squares cancel, so it's not quadratic. I brought the 4 here across and it became minus 4, so that's where the 12 came from. And divide by the minus 16, you get m is minus 3 over 4. Now I went to start it over here, but because you're squaring this minus 4, you end up like those two lines there are identical. So you end up with the exact same thing. So you're going to get the same answer. So the equation of our tangent was y equals mx. And I now know what m is. So it becomes y equals minus 3/4 x. So that's fine. That's a tangent. But the question, did say that we had to find two tangents. But if you look at this, the first tangent I pointed out is this one here. It goes from the origin straight down through A. That tangent is the y-axis, and the equation of the y-axis is x equal to 0. So that's your second tangent.